Hey guys, welcome to a new video in this Q-learning project that we're doing. In the last video, we went over different kind of initialized function for our Q-table and reward matrix, and we went over some of the different kind of attributes that we're going to use for Q-learning and also the parameters for updating our Q-table with the Q function. So in this video, we're going to do the actual training process, and we're going to implement the functions for getting an action from a given state that we're in, and then we're going to implement the epsilon greedy algorithm, where sometimes we're going to explore the environment and sometimes we're exploiting what we already have learned about the environment when we're operating with our agent in the environment. So first of all, here let's talk about the get action function here, where we have this parameter here, the current state. So when we want to take an action or get an action from the environment, we have to give it the initial state that we're in now, or the current state that we're in now, and then it will return the action that we're going to take from this epsilon greedy approach or algorithm. So first of all, here we're going to have a vector with the valid actions that we can take for the current state. So first of all, we have this for loop here that runs through all the actions in our reward matrix. So we run through all the actions from a current state that we're in now. And then we check if the action is equal to -1, because we all know in our reward matrix, if the index is -1, then there's no connection from that room to the other room, or we can't take that action because there's no connection between the two rooms by taking that action in the current state. So if it's not equal to -1 here, we know there's a connection, and then we push back that action to a vector here, which contains the valid actions, and then we can use these valid actions here to actually take one of the actions by this epsilon greedy approach. So first of all, here we're going to have this random device here again, so we can get a random number when we're doing this exploration and exploitation trade-off. Then we need a random number for that trade-off. So first of all, here we're going to have this uniform integer distribution and also a uniform real distribution. And the difference between those two here is that here we have only integers, and down here we have floating point numbers, which we get where we get a random number between 0 and 1 in this case here, and then we're using this for exploration, and so we can tell the agent when it should explore and when it should exploit the environment. So first of all, here we're just returning a random integer between 0 and the number of the valid actions. So let's say we're in room 0, for example, then the size of the random valid actions here is 1. So then we can only have we will only get the random number 0 or 1, and we only want to get the 1 because that's the only valid action to take for that given state. And then we have this exploration trade-off here, where it will return a value between 0 and 1.0, and this here will be the epsilon. It will be the epsilon value here for our exploration. And then we're going to go down here and create some threshold value for our exploration rate here, which will just be this random exploration number here between 0 and 1. And then we can check if the epsilon value that we have set up is bigger, is less than the exploration rate threshold up here with the random value. And if it's bigger than the epsilon value, then we know that we should exploit the environment. But if the epsilon value here is bigger than the threshold up here, and the threshold up here is the random number between 1 and 0 here, so this is the exploration and exploitation trade-off setup here, and we check in the if statement here. And if the epsilon value is greater than the exploration threshold, we just return a random action from the valid actions that we have in this valid actions vector up here. But if the exploration rate threshold here is greater than epsilon, then we want to exploit what we already know about the environment. So first of all, we're checking if the number of from the current state and the room that we're in now and the current state, if the number of visits for that room is equal to 0, then we are just incrementing the number of visits for this room that we're in now, and then we return the maximum element. In that for the valid actions in that room. So in the first example, and we have only visited room 0 times, then we will return the maximum value in the Q table, or else we go down here and check if the number of visits is less than the number of actions possible to take in a room. So we set up this because we don't want our agent to be stuck in a room, and it will get stuck if it just chooses the highest Q value in the Q table each time. Then we'll get stuck between for example room 9 and 10, and then we'll just go back and forth between that room because the biggest Q value is just from room 9, it is to go to room 10, and then the biggest value in room 10 is to go back to room 9. And if we visit it the second time and we just take the biggest value, or like the highest value again, then it will go back to room 10, and we don't want our agent to do that. So we need to have this function here, or like this if statement here, that checks like if the number of visits is less than the number of actions that we can take, like the number of different actions we can take from that room. And then we check if the like those visits and like the number of visits for that room is equal to the number of actions. And if they are, we just reset the number of visits here, or else we will like have this k here for like the number of visits. So this will be the kth element, and we're going to use this find kth largest index of the function up here. So this function, all it does is it takes a vector here, and then it sorts the vector, and then it finds the kth largest element. So let's say we have visited the room one time, then it will return like the second largest element in like the Q table here. So let's say we have like, for example, a room here where we can take two different kind of actions, and we have the greatest value, or like the highest value in the Q table, and we have already visited the room once. Then we will take the second highest value, so we don't get stuck like between two rooms, and we'll just go back and forth from that. So this is what this find k largest index does. And if we have multiple rooms, like for example room 5, and we want to visit room 5 multiple times, then we don't want to just go back and forth between some rooms, and we actually like want to like take the number of times we have visited that room. We want to take that number's largest index in the Q table, and then choose that action to maximize the reward for the agent when it's learning over the episodes. And then down here we just increment the number of visits here by 1 when we are exploiting the environment here, and return the index of the largest here. And then the index of the largest here is the action that we're going to take for that room now, by using this exploitation here and doing, or like taking an action from what we already have learned about the environment. Or else, if we're exploring the environment, we just take a random of those actions, of the valid actions down here, which is the vector containing the number of different kind of actions we have. We just take a random action from that list here, or a vector here. So we return, we have a current state here that we pass as a parameter, and then we return a new action that we're going to take from that current state. Then we can go down here and take the actual action. So first of all here, we're going to give it the current state here that we're in now. And then we take an action here with the function that we just implemented here. So we give it the current state that we pass to this function as well, and then we have this get action here, and it will return the action, and we store it in this action integer variable here. And then we set the new state, because when we're taking an action, we will transition into a new state, and we set that action that we're taking to the new state. So the action we take is equal to the new room that we enter, and then that room will be the next state that we go forth with. And then we need to update our Q table with the Q function here. So first of all, we're going to calculate the current state action value. So I'll split the function up here in two parts, where first of all we're going to calculate the current state action reward, and then we have the reward here, and then down here we have like the maximum reward, and then down here we have this like Q function here, where we're going to combine all of these different kind of parameters here with the learning rate and the gamma rate for like the future state action reward and the current state action value. So let's start up here where we have this the current state action value here. It will be equal to the current state that we're in now, and then the action we're taking from this get action up here. So this will return a value in the Q table, and we will store it in this variable here, current state action value from the Q table. And the reward that we're going to receive for taking this action here is the rooms vector here, and then the action, like the index of this action here in the rooms, and then we want to get the reward for that room by taking that action, and then we store it in this double variable reward here. Then we can go down here and see that we check now if the room that we're going into is already visited, and if it's already visited, we just set the reward to 0, because then we have already collected the reward, and we want to teach our agent needs to learn by interacting with the environment that it is not good to go back to a room that it has already been visited. So that's why we're setting the reward equal to 0, because it has already collected that reward for that given room. And then we have this reward here where we just like for each time we're taking a new action, we just like apply this, or like we just add this reward here to the max received reward for an episode. Because when we're going to train our agent, we want to see like how much maximum received reward did it get for each episode. So for every action we're taking, we just add this reward here for each action to the max received reward here that we're going to use later on. And then for the max future reward for the next state, by taking the best action in the next state, and then we use the gamma value to scale that. So we take the maximum element, or like we take the maximum value in our Q table for the next state. So after we're taking that action, we will return a new state, and then we take, for that state, we take the highest element. We take the highest element in the Q table and we store it in this max parameter here, or like this max variable here. And then we set that the future state action reward is equal to that maximum value here. So we're using iterator in this example here, and then we need this star operator here to get the actual value for the iterator, where we're iterating through the Q table for the new state and finding the max element. So down here we have the Q learning equation, or like function, where we combine the different kind of the values here that we have, and then we have this new Q value here that we can update our Q table with. So first of all, here we have this value here, which is the Q value for the current state, and we set that equal to the current state action value plus the learning rate. So this depends on how fast we want the agent to learn. And then we have this parentheses here where we have the reward for the action taking, and then we have this gamma value or discount factor for the future state action reward that we have calculated. And then because we're using temporal difference learning, we subtract the current state action value for this reward here for like the future state action reward. So this will return the new Q value here that we can go down here and update our Q table with. So the Q table here, we have the index of the current state that we're in now, and then we take a new action, which is this index here, and then we set this index here of the Q table equal to the new Q value that we have calculated up here by taking an action and getting reward for that action, and then we update our Q table with the new Q value that we have calculated, as I explained in some of the previous videos where we went over like this different kind of steps in Q learning and the way we are implementing this Q learning project. So this is just to display like the different kind of states and the different kind of actions that the agent takes during training. And then when we have visited this room here and we're taking an action, then we set that room visited to true, because then the agent will learn that it should not go back to that room again when it has already been visited. And then this function here returns the new state that we get for taking an action. So we take an action, we get an action from a state, we take a new action depending on the epsilon greedy approach, and then we return a new state here and update our Q table. So this is like the flow chart that I showed you in the slides in some of the previous videos. So when we have taken an action here, we return the new state that we're in now, and then we can just do this over and over again until our episode terminates. So this will run over and over again until our episode terminates after let's say a fixed number of time steps. In this example or this project here, we're just going to choose 6 as the fixed number of time steps. So the agent for each episode, it can take 6 time steps, and when the 6 time steps is reached, or when it has taken 6 actions, then the episode will terminate and we will need to start over again from a new episode. So down here we have this run episode function here where we're going to set the current state to an initial random state. So we get this random state here as we talked about in the previous video where we went over how we get a random state every time we run a new episode. So we set the initial reward here to the reward for the current state, or the room that we're in now, and then we just add that initial reward to the max received reward that we're going to have for each episode that we're running. So we get a max received reward for each episode, and then we can use that to evaluate our agent and see how it learns over the number of episodes. And then we have this while loop here that just runs until an episode ends. And in this case here, we have this if statement here where we have this step count here, which is just incremented for each time we're taking an action. So when the step count here is equal to max steps per episode, which in this case here is 6, then it will terminate the program here, and we will push back the max received reward to a vector that we're going to use for plotting some of the data. And then we just reset the maximum reward received, and then we can do the whole process here again and start a new episode. So this function here only runs one episode, and then we will have another function that runs multiple episodes and actually doing the training of the agent. So this is the training function down here that I talked about, where we're going to train our agent and we're going to run several of these episodes and functions that I just showed you up here above. So first of all, we're going to train our agent. We're going to initialize the Q table first of all, and we're also going to initialize the reward matrix. And I showed you these functions here, how we initialize the Q table with zeros in all indexes, and also like how we set up our reward matrix for the different kind of rooms, and telling like the agent which rooms can it go to and which ones can it not. So we talked about these videos here, like these functions here in the previous video, so you can go check that out if you want to. If you want to know like what these functions does, and also like how to implement them. And then we're going to do the actual like training. So we have this, we just see out that the training has now started. And then we have a for loop here that runs through all the episodes. So we start at episode 0, and then we run each episode here until the number of episodes that we choose. So this is the parameter that we pass in the Q-learning constructor. So in this case, we're just having 5,000 episodes. So we run this function up above that we just showed you for running an episode. We will run this function here 5,000 times and update our Q table, taking action, updating, taking actions, and then running new episodes all over again when you have reached the max number of time steps. And then we have this this set initial random state here, so we just set it to true, and there's no initial state that we want to set, so we just get a random initial state for every episode that we're going to run. And then we run the actual episode here with this function that just uses this random initial state. It takes an action, updates the Q table, and then it just keeps going over and over and over in that until it reaches 6 time steps, and then it will terminate the episode, and we'll go down here, store some of the values here for later use and for plotting and evaluating our training. And then we're going to update our epsilon value, because we have this epsilon decay rate. So for each episode that we're running, then we're decaying our epsilon. So in the start, we start with epsilon at 1 because we want to explore as much as possible in the environment, and then over the number of episodes, we want to decay that epsilon ratio. Or like that epsilon rate, so we explore it less and less, and then we the longer we get into our episodes, the more we explore what we already know about the environment. So we're going to do that with this equation here, where we're going to decay our epsilon value with an exponential decay. And then when we have done this here, we have trained our agent, and we can see out that the training has done, and we can store some of the data that we have gotten from the training process here to a CSV file that we can then later on like process and do some data analysis on, and plot some of the training processes, and also some of the parameters that we can later on then tune to get the most optimal training process and get the best possible result for our agent. So this is the whole thing for the training loop, where we have an episode that just runs for a number of episodes, and we get initial state, we take actions, we update the Q table, and we terminate when we reach the max number of time steps, and then we just run this all over again for thousands of times. And then when we've done that, we have trained our agent, and we have tried to estimate the reward matrix with our Q table, and then we can just use that Q table that we have learned to actually deploy our agent. So this is what we're going to do down here. First of all, we just have the true follow-up here that just displays the trained Q table at the end of the training. And then down here we have the actual function that just deploys the agent. So when we're deploying an agent, we just want to set the epsilon equal to 0, because we only want to exploit what we already learned during training, and we don't want to explore anything, because now we have estimated and we have the optimal Q table. So like for each step, or like each action we're taking, it will be the optimal one, because we're taking the maximum value in the Q table. So we set epsilon equal to 0 here, and we get a random initial state. In this case here, we set it equal to false, which says that we will set the initial state ourselves, and we set it to start at room 0. And then we just run a new episode here with the epsilon value of 0, and then it will actually like use the Q table that it just has learned, and then it will take the actions with the maximum values and the actions that will return the maximum expected reward for the agent. So this is all we have to do for training our agent and deploying an agent, and we can use the same function with just running an episode. So when we're deploying an agent, it is the same as just running another episode as we did in the training, but with an epsilon value of 0, because we only We only want to exploit the environment and use what we have learned in our Q table. So down here, I just have this function here to output the data to CSV. So we just have a follow here that just outputs some of like the expected returns per episode and some epsilon values and learning rates and stuff like that. So we're going to have another video where I'm going to explain like how we can do these test setups and also how we can plot the data that we have gotten from training and how we can tune some of the parameters. So I'm going to cover that in the next video, where we're going to load this CSV file into Python, and then we're going to do some data analysis and doing some tuning on the parameters, so we can optimize how the way the agent is learning, and also how to find the most optimal path. So if we run this program here, we're actually going to do the actual training of the agent, and we can see that here in the terminal it will run through all the episodes here. So for every time we get something out in the terminal here, it is by taking an action. So we're in a state now, and then we're taking an action, we're receiving a reward. So each time we see like something here in the terminal, it's a new action taken, and then we receive a reward, update the Q table, and we just do this process over and over and over again. And in this case here, we're training our agent for 5,000 number of episodes. And then we can see that here we have now trained our agent. So first of all, like all of these here is the training process that I'm showing you here in the terminal. And then down here afterwards, when we're done training, we write out here training is now done, and then the data is formatted or sent out to the CSV file for data analysis. And then we display the Q function, like the Q table here with the maximum Q value. So let's say, for example, we start in room 0, then we take the value with the maximum Q value here, which is indeed by taking this action 1 here. So we take this action here and go to room 1, which is also the case down here where we're deploying our agent. So this is the final Q table where we try to estimate the reward matrix that the agent didn't know anything about in the start. So down here, when we're using the Q table, we will deploy our agent here. And first of all, we get an initial reward of 25. Like you can see the predefined rewards in one of the previous videos. In the first video I did of the project here, where I showed you an image of the map. So in the first room here, we get an initial reward of 25. And then we start at room 0, and then the next state we go to, or like the next room we go to by taking this action here, is 1. And then from state 1 here, we take the next action and we go to room 5, and then from room 5 to 7, 5, 9, and then 10 at the end. And we're now taking 6 actions, and we've tried to estimate or like try to maximize the reward. So indeed the agent has learned the most optimal path from room 0 or like some other initial random state, and then taking 6 time steps and then maximizing its expected return by only taking 6 time steps for some random initial state. So in this case here, we're returning a maximum reward of 95. And if you try to like sum these rewards up here, it is indeed 95, which is also the most possible reward that it could receive by taking 6 actions or like 6 time steps from room 0. So we can see that we have now trained our agent, and we're able to deploy it, and the agent is able to find the most optimal or like most efficient navigation strategy from one room to several other rooms to maximize its expected return. So this is like the end result of our Q-learning project here that we implemented in code. And in the next video, we're going to do some more analysis on like the agent that we're trained now and when we have deployed it, and we're going to tune some of the parameters, and I'm going to show you how we can tune these parameters in Q-learning, because it's very important to get the most optimal training results and also to get the best results when we're deploying our agent and finding the best paths between some different kind of rooms. And all of this can also be implemented and applied for other applications. So this is just a simple, like a more simple, kind of a more simple example. It could be more complex applications where in also like real practical examples where you could use this kind of approach with Q-learning, because it's kind of like the same where we just have these actions that we take, and we have some initial states, and we're in a current state, we take an action, we get the reward, and then we just run all this here for each episode, and then we just run it for a number of episodes, and then we're training our agent, and the agent, when it gets deployed, it will exploit what it has learned by using the training. So it can be used for a lot of different kind of things, but we'll talk more about that in the next video. I'm going to show you some graphs of like the results and also how we can tune these parameters, as I already said. So thank you guys for watching this video, and remember to subscribe button and bell notification on the video, and also like video if you like the content and you want more in future, and it just really helps me and the YouTube channel out in a massive way, and I just really appreciate your support. So I'm currently also doing a computer vision tutorial in OpenCV with C++ and an algorithm data structure tutorial in C++ as well actually. So if you're interested in one of those tutorials, I'll link to one of them up here, or else I'll just see you in the next video guys. Bye for now.